substitution is one of my favorite ways to solve a system of equations. And when I say system of equations, Gavin, what do I mean?
Show my system of equations?
Yeah. Like a set, right, of two different equations. So we're going to do kind of a sequence here so you can see what's happening. If I said 2x plus y equals 10 and said solve it, why can't I solve that? I have two variables. I need another equation. If I said x equals 3, now could you solve it? Yeah, what would you do?
Substitute.
Substitute, perfect word. Substitute that 3 in for x, and now solve it, okay? No problem. What if I had 2x plus y equals 10, and x equals y plus 4?
Still plug it in.
Okay? I'm going to do the same thing. I'm still going to substitute, but instead of just plugging in a 3, it gets a little more complicated. I'm going to put this whole expression, y plus 4, in for x. And what would that look like? Well, you'd have, instead of 2 times x, you'd have 2 times y plus 4. And the good news is we're down to one variable. That was the point, because now we can solve it. So this is what we've done so far. What we're adding today by rearranging means that it's not going to look this straightforward. So now we're going to have to be a little bit more creative. So let's look at practice A. X minus 3y equals negative 7. And 2x minus 3y equals 4. Excuse me, that's not going to play well on the video. I'm going to have to edit that out. Thank you. Oh my goodness. Just read my mind. Okay, so how does this look different than, say, this one? What's different?
That one
Has the answer. What do you mean?
for you to substitute it.
It's easier to substitute because why? X is one thing. What do we say, Gavin? What's that? We have like a couple catchphrases, right? X is
a variable.
It's a variable. It's
By itself.
Thank you, Ethan. It's by itself. It's isolated. We always want to isolate the variable. It's very rude, okay? Very clicky, okay? But that's okay. Math is perfect. We don't question it. Okay, we want to isolate the variable. It's an introvert. It wants to be by itself. It's happy, okay? So we don't have an isolated variable here, but we can get one pretty quickly. Can you see how, not with both of these, only one of these equations, you can get an isolated variable in one step? Can you see that? Which one of these has a variable that's almost alone? The top one, right? Which variable?
X.
The x. Now, is this one almost alone? No, because it has that 2 there also, so you'd have to move that and then divide. One step here gets you the x alone. So, let's do that. Let's change this equation and say x equals, what happens to that negative 3y when you move it to the other side?
Positive.
It becomes a positive 3y, and that stays the same. So now we have this new equation, and it looks just like this. So now we can take this 3y minus 7, and where do we plug that in?
Where x was?
Yeah, for the x. So we get 2, instead of 2 times x, we get 2 times 3y minus 7 minus 3y equals 4. Now, what's a common mistake that someone would make at this point, Diana? In my head, not distribute. So you guys, I always do this. I don't want to forget that poor 7. Now this is rude, okay? This 7 does not want to be excluded. It's not an introvert. You have to distribute it. That's fair, right? You don't want to hear that little brother going, it's not fair, I didn't get one. Okay, so we distribute it and we get 6y. Let's keep it the same color. My cat. 6y minus 14 minus 3y equals 4. Then, what do I have to do? Combine, again, these are our catchphrases we want to just hammer into our brains. Combine like terms. So we combine the 3y and the negative 3y. Always keep those signs right next to it there. And we get 3y minus 14 equals 4. Now I still want to isolate the variable. I want to isolate that y. So I have to add 14 to both sides. And then I get 3y equals 18. Divide by 3. Divide by 3. Y equals 6. Am I done?
No, we gotta go back and do the whole thing again.
Well, not the whole thing. We found y, and now we have to find
X.
x. It's only fair. And what does x equal?
3y minus 7.
Yeah, so we just go do. We're gonna plug in the 6 for that y. So we get
18.
x equals 3 times 6 minus 7. 18 minus 7, which equals 11. So, final answer is x, I'm going to write it as an ordered pair with your x and y, 11 and 6. Or you could say x equals 11, y equals 6. Am I done now?
Yes.
No. I'm not going to do it, but you could check it by plugging in those numbers to both original equations.
You're done.
That was fun. I mean, if you don't think that was fun, I don't know how to help you. Let's just look at practice B. We're not going to solve it, but if we were, 4x minus y equals, 51? And then, 41, sorry, 2x. Someone read that next one to me. 2x. Thanks. All right, here's my system. Which one of these equations has the easy one to isolate the variable?
It says 26 on the book.
Not in mine. All right, which one of these has the easy variable to solve for, where you just have to move one thing? You guys see it?
The second one?
The second one, yeah. This one's tricky, because it's got that negative. You might want to say this one, but you go, ugh, negative. Who wants to deal with negatives? Say I. Nobody. All right. So here, look, we have, what you're looking for is something like that. So what would we have to move?
2x.
We would just move that 2x over here, and it would become negative 2x, and then same. All right.